Hi everyone, welcome back to the coding series. Today's problem is find a peak element in a 2D grid. Let's understand the problem statement. A peak element in a 2D grid is an element that is strictly greater than all of its adjacent neighbors to the left, right, top and bottom. Let's understand. Given matrix is 1, 4, 3, 2. This is 2 cross 2 matrix, right? So what this line states that is our given matrix is surrounded by an outer perimeter with a value -1 in each cell. Okay, now let's find the peak element. Okay, let's start with 4. Can I say 4 is a peak element? Because it is greater than all of its adjacent neighbors. 4 is greater than 2, 4 is greater than -1, 4 is greater than -1, 4 is greater than 1. Now let's check for 2. 2 is less than 4 and 2 is less than 3. So 2 can't be a peak element. Now let's check for 3. 3 is greater than 1, 3 is greater than 2, 3 is greater than -1, 3 is greater than -1. Okay, that means 3 is also a peak element. Now 1. 1 is not a peak element because 1 is less than 4, 1 is less than 3. So here what you have to return? Okay, you have to return index of a peak element. Okay, now here we have multiple peak elements. So in that case you have to return any one of its index. Okay, here they are returning index of number 4. Okay, that means this number 4 is lying in 0th row and first column. So 0, 1. Now let's dive into the approach. How we can solve this? We can solve this using binary search. Okay. Now let's consider one example 3 cross 3 matrix 10, 20, 15, 10, 20, 15 and 21, 30, 14, 21, 30, 14 and 7, 16, 32. 7, 16 and 32. So this is 3 cross 3 matrix. As I mentioned, this matrix will be surrounded by outer perimeter with value -1 in each cell. So that can be like this. Okay. Now let's find the peak element here. 10 can't be a peak element because 10 is less than 20. Sorry, 10 is less than 20, 10 is less than 21. Okay. 21 also can't be a peak element because 21 is less than 30. 7 also can't, 16 also can't. But 30 can be because 30 is greater than 20, 30 is greater than 21, greater than 16 and greater than 40. Now 20 also can't, 15 also can't, 14 also can't. But here 32. 32 is greater than 16, greater than -1, greater than -1. So this is, so 32 is also a peak. Here we have 30 and 32. Okay. Since you have two peak elements, so you have to return any one of its index. Okay. This index is first row and first column. This one is second row and second column. Okay. Now let's see how we can solve. Okay. Now as I mentioned, we are using binary search to solve this problem. Okay. That means you have to consider low and high and you have to calculate mid, right? Okay. Now let's see what you have to point out to low and what you have to assign it to high. Okay. Now before to that, okay, how we will solve this problem is first we will pick any one of the column from this matrix. Okay. So that denotes the mid. Okay. So you have to pick any of the column, you have to first calculate the mid. Mid will denote the that column. Okay. Now here low will be because this is the 0th column, this is the last column, that is 2. Okay. So low will be 0 and high is 2. Okay. Now you have to calculate mid. So for mid it is low plus high by 2. That means in this way you will pick any one of the column from this matrix. So 0 plus 2 by 2, that is 2 by 2, that is 1. So our mid is pointing here. Okay. Once you pick the column, okay, now you have to see what and all elements are present in that column. Okay. Now, so if you pick that column, these are the elements, right? Now, after that, you have to find the maximum element from this column. Okay, so here maximum element is 30. So, before to that, okay, how you decide whether that element is a peak element or not? Okay, you will decide whether this element is peak element or not is based on the neighbors, right? Based on the neighbors. Okay, that means this peak element should be greater than all of its neighbors. That means top, bottom, right, and then left. So it should be greater than top, it should be greater than right, this one should be greater than right, this should be greater than bottom, this should be greater than left. In that way, you will decide that element is a peak element, right? So can I say after you find the maximum element, okay, that means can I say for this the top element, that means this element, this number will be greater than top and greater than bottom? Yes, right? That means can I say my vertical side for this element is sorted? Because if it should be a peak for top, like it should be greater than top and bottom. Here, after you find the maximum element, so we are sure that it will be greater than its top element and bottom element, right? So in that way, our vertical side is sorted. Now you have to check the horizontal side. You have to check this, right? Now, for clear understanding, I will interchange these numbers. Okay. Now, my this is the maximum element, right? Greater element from this. Okay. Now, for this top element will be -1 because this matrix is surrounded by outer perimeter. So -1. That means 30 is greater than -1 and 30 is greater than 20. That means its top and bottom elements are less than this, right? So our vertical side is sorted. That means whenever you calculate mid, that means mid denotes the which column you have to pick. Okay. After that, you have to what you have to do? You have to uh, uh, find the greater element. If you find the greater element, then we are sure that it will be greater. That means it's that means the elements that are above to this and below to this will be less than this, right? The elements above to this and below to this will be less than this. That means our vertical side is sorted. Okay. Now you have to check the horizontal side. Okay. First, for this we will derive, like first for this we will see how we will write the code. Okay. Now once you calculate the mid, okay, that means our column side index is fixed. Now you have to find, okay, you have to find the what? Greater element from this column. That means first, that means you have to find the row. You have to find the row in which the greater element is present in that column. Okay. Now I will take, you have to find that row, max row. Initially it will be pointing to the 0th row. Okay. For I equal to 0, I less than how many rows? There will be 3, total 3 rows. So n minus 1. So I less than 3 and I plus plus. Okay. Now if matrix of, okay, matrix of I of mid, because you have to check each, you have to iterate all these elements in this column, and you have to find the row, you have to find the row where our maximum element is present. Okay, now if it is greater than mat of max row of mid, if it is greater than, then what you have to do, you have to assign that max row equal to I. Okay, in that way you will get where our maximum element is present, because our mid is fixed, because in this column only you will check. Okay, but now our column is fixed, now you have to check the row. In that way you are checking the row where our maximum element is present. Okay, now let's see. Okay, initially let's find, initially when I equal to 0, what is mid is equals to 2. Okay, mid anytime it will be 2, because sorry, mid is 1. When you calculate in the first iteration, it will be 1. Okay, so when you calculate mid is 1, so mat of 0 of 1 is 20. That means 0th row and first column, so 20. 20 is greater than mat of max row of mid. Max row of mid is 0. Okay, max row of 0 is mid, so 0 comma 1, again 0 comma 1, so that will be 20. 20 is greater than 20, no. Now I equal to 1, I equal to 1. So when I equal to 1, this is 1 comma 1, right? So mat of 1 comma 1 is 30. 30 is greater than max row is 0, right? Initially, so 0 of 1, it is 20. That is greater than 20. Now you will update maximum row to I, that is 1. Now when I equal to 2, I equal to 2, you will check this element. So that is 16 is greater, 16 is not greater than 30, right? Because you have updated this max row to 1, so 1 of mid, that is 30. So that will be 30. So in that way you will get the maximum row. Now max row is pointing to 1. After this iteration, max row is pointing to 1 and mid is pointing to 1. Now when you check mat of max row of mid, okay, what you will get? You will get max row is 1 comma 1. So 1 is 1 comma 1 is 30. So in that way we found the greater element using this. Okay, now so as I mentioned what our this one, what vertical side is sorted, now you have to check the horizontal side, right? So we found this element, that means this row is fixed now. Okay, you have to iterate in this, what, not iterate, you have to check this left side element, this right side element. Can I write this left side element as, for this, now 21 30, right? 21 30, and what is that, 14, I guess, yeah, 14. Since max row and mid we have, max row comma mid we have, so for this can I write mat of max, because row is fixed now, mid minus 1. That means this is left element, left value for this, and right value will be obviously mat of max row of mid plus 1. That is right value. Okay. Now you will calculate this. Now after that you have to check, and these two what values should be less than, if you are checking this can be a peak, now it should be greater than this it should be greater than this also. Right means that means it should be greater than left and it should be greater than right. Okay. Now let's see. Here 30 is greater than 21. Okay. You will check. Okay. Now 30 is greater than 14 also, because from this you will get left value as 21 and right value as 14. In that way, using this you will calculate 30 is greater than 20, 30 is greater than 14. Okay, that means since we are since our vertical side is also sorted and horizontal side is also sorted, because this is greater than both the values, both the sides. So can I say that element is a peak? Yes, right. Now we will write that here. Okay, same, nothing, just you have to, since you will calculate left using this formula and what using this, okay, and right using this, okay. And before to that you have to check if mid is, to calculate left you have to check whether if a mid is greater than 0. For same, for this you have to check whether if mid is less than n minus 1. N means number of rows, sorry, number of columns in an, because if to, because it should not throw the any error, right? Because if it is, if our mid is only pointing to 0 minus 1, it can't access, right? So for this, so in that way you will assign this left value to this formula and right value to this formula. And later what you will check, and after you finding this you will check whether our mat of max row, mat of max row of mid is greater than left and greater than right, this one. Okay, for this it should be greater than left, it should be greater. If it is, then you can just return inside this you will return max row, because 1 comma 1, so max row comma mid, this will give the index of the peak element. Okay, now so for this you have calculated the maximum element in the column. Next you will calculate this. Okay, now since here this is a peak element, using this you will calculate. But what if our right side elements differs? Like now we have 21, 30, here I will keep 31. Okay, this right side element. Okay, this right side element, instead of 14 I will put as 31. In that case this is sorted, but this is not sorted because 30 is less than 31. Okay, in that case what you have to do is, okay, since our left side is sorted, okay, but right side is not sorted. Okay, that means sorted in the sense, for 30 this is greater than 30 is greater than 21, but 30 is less than 31. That means this is not a peak element. Okay, now our mid is pointing to first column. This one is, our low is pointing to the first column because 21 lies in the first column, 31 lies in the last column. Okay, so here, since our greater element lies after this mid, okay, greater element is right beside this element. Okay, our greater element is right side of the mid. Okay, so in that case I can be assured that our peak will be lying to the right side column of this mid. Okay, not the left side column. Okay, in that way I will move my low pointer to mid plus 1, low equal to mid plus 1. That means low will be pointing here. Okay, in that way, you will eliminate all the left columns to the mid. Okay, and you will eliminate all the left columns to the mid, and you will check only all the right columns to the mid. Okay, you will eliminate this, and how you eliminate? You will move your pointer to here to mid plus 1. So in that way, you will eliminate all the elements, all the columns to the left side of the mid, and you will check only all the columns to the right side of the mid. Okay. Now, for that, what you will write? If our right value is greater than our this mat of max row of mid, if it is greater, then you will move our low pointer to mid plus 1. Else, that means if it is less than. Now we will interchange 31, 30, 21. Okay. Now this is greater. Right side element for to the right side of the mid. This is greater only because 30 is greater 21, but 30 is less than 31. In that way, I can say our what peak element will lie to the left side of the left. Our peak element will lie in the left columns of this mid, not in the right columns of this mid. In that way, I will move my high pointer because high pointer will be here to mid minus 1. That means high will be mid minus 1 means here. So in that way, I will move my high pointer to mid minus 1. Okay. Now, since, okay, so now, okay, will be, this all will be inside the for loop, right? Inside the for loop of low less than high. Okay. Now, for low less than high, you will calculate everything and then you will move, right? Now we will just using the same example 10, 20, okay, 10, 20, 15, 21, 30, 40. So 10, 20, 15, okay, 21, 30, and then I will make this as 31 for now, and then what is this next elements? 7, 16, 32, 7, 16, 32, 7, 16, and 32. Okay. Now initially our low will be here, high will be here. Okay. Now our using formula, you will calculate mid, that will be pointing to here. Okay. In that way, you have to find, okay, you will pick this column. Okay, you will pick this column and you will find the maximum element, greater element. Okay, that is here. Okay, in that way, our top elements will be sorted. That means sorted means our vertical side is sorted for this. If we are thinking this can be a pick. Okay, now we have to check its right and left. Okay, since left is less than this, but right is greater than this, but this element is greater than this. In that way, in that way, this one will not satisfy. Okay, now right value, this one, because you will keep all inside the for loop, for low less than high. Okay, all the calculations what I have mentioned earlier, it will be for low less, it will be inside this for loop. So our right side value is greater, 31 is greater, then you have to move your low pointer because peak elements will lie to the right side of this column. Okay, right side of the mid. Okay, now now 32, you will move your low pointer. Okay, low pointer to here. Okay, now again, since in the first iteration, low equal to 0 and high equal to what 2, you will calculate mid equal to 1. Okay, now our first iteration is done. And when you checked in the first iteration, so you are moving your low pointer to here. So now low will be 2 because mid plus 1, 1 plus 1, 2, and high is 2. Okay, high is 2. High is 2. Okay, now you have to calculate mid. Mid is 2 plus 2 to pick the which column. So 2 plus 2, 4 by 2, that is 2. Mid is 2. Now you will pick this column. Once you pick this column, you will find the the greater element. So that will be 32. Okay. Now you have to check for 32. That means this vertical side is sorted. For this 32, vertical side is sorted. Now you have to check 16. 32 is greater than 16? Yes. 32 is greater than what this left side element, sorry, right side element is -1, right? Because our matrix is surrounded by outer perimeter with the value in each cell -1. So 32 is greater than -1. Okay, so in that way, in that way, this condition will get satisfied because mat of max of row of mid is 32. 32 is greater than -1, 32 is greater than 16. Because before to this, okay, you have to initialize our left to -1 and right to 2. You have to initialize because for this, for this, for this, its right side element is -1. That is not in the matrix, but we are assuming that this is surrounded by outer matrix. So in that way, you have to keep. Okay. So in that way, this will be what executes. Then you will return max row comma mid. So what max row you will get? You will get max row is where your what greater element present, in which row that greater element. Here it is 2 and your mid is also 2, right? Mid is also 2. So you will return 2 comma 2. Okay. So in that way, you will solve this problem. Okay. Now space complexity. Space complexity is of 1 because we are using only constant variables. Now time complexity. Now you consider low and high as m. M. Okay. Since we are using binary search to calculate, to iterate, okay, to iterate, we are using again one for loop inside this to calculate which is a greater element in that column. Okay. That means you think there are what n numbers in a column. Okay, you have to iterate, right? So for each binary, okay, but that means for total binary, so for each iteration you will iterate n elements, right? Of log n of n into, okay, of n into, and for the binary search, what is the time complexity? It is, say, since we are iterating till o to m, our binary search will be O of log m. That means O of n log m. If you take n rows and n columns, then it will be O of n log n. This is for what? N rows and m columns. Okay. This is for n rows, m columns. That means n not equal to m. Here n rows, n columns means m equal to n. Okay. So in that way. And here they mentioned that you have to solve using O of m log n or O of n log m. Okay. Now, so as I mentioned, we have solved, we have achieved using that. Okay. Now let's see the code. Okay. Here initialized low, initialized high. Okay. Because high mean for this, how many like columns are present. Okay. Now you are iterating low to high and you're calculating mid and you're initializing your row. Now first you're initializing. In that way you'll pick one column, okay, using mid. So in that, if you think our what the greater element lies in the first row, initially you have to assign like this, and while iteration you will update this max row, and for so you have to initialize left value, right value, because to the -1, because for the edge cases this will be -1, and left and right can be -1, -1. So now if mid is greater than 0, okay, because to calculate mid comma -1, it should be greater than it should be greater than 0. So in that way, you will calculate left and right values for that what maximum element, what we have got, what we are getting using this. Okay. Now after you check left and right, you have to check whether our that maximum element is greater than its left and right values. If it is greater, you can just return its index. If not, you have to move your high and low. Okay. Now let's submit this. See, all test cases are passed 59, 59. That's all for today's guys. If you have any questions, please do add in the comment section. Okay. Like and subscribe for more videos. Thank you.